In California, catastrophe strikes one of America's most vital intersections.
To witness that much steel collapse in a fiery mess, it's scary.
In Australia, a demolition disaster in the nation's capital, Canberra.
Any event involving explosive is inherently a dangerous thing.
Tragedy in Illinois as a pioneering stadium collapses.
The scene was chaotic. The devastation was total.
And in Michigan, a crucial shortcut cracks at the seams.
It was one of the worst segments of road that I've ever driven on in the United States.
With big builds, even the smallest mistake can be a huge disaster. From miscalculations to misunderstandings, some with deadly consequences. These catastrophes are every engineer's worst nightmare. With big construction, engineers try to prepare for every possible outcome, but sometimes the most unlikely fail can strike the hardest. Like this disaster in California, a catastrophic collapse on a major freeway.
A tanker truck spewing flames, smoke throughout the Bay Area, absolute disaster.
A raging inferno devastates a supersized structure.
To watch a road that you've been over a million times just fold like a taco, no words can describe it. It was really shocking.
And a race against time to get this vital road back up and running.
This interchange carries more than 250,000 vehicles a day. They needed to get this route open again, and fast.
San Francisco, the city by the bay, sits at the tip of a 65-kilometer-long peninsula surrounded by water.
For decades, the only way north from the peninsula was by ferry. But all that changed in the 1930s when the city added not one, but two iconic bridges.
Bart Ney is the California Department of Transportation's Chief of Public Information.
We're in the Bay Area. We have always built the future. Two massive and historic bridges. The Golden Gate Bridge in San Francisco and the San Francisco-Oakland Bay Bridge here on the East Bay. All of the roadways here sort of feed towards the Bay Bridge, which is the gateway to San Francisco.
Although the Golden Gate gets all the attention, in reality, the 7-kilometer-long Bay Bridge is the area's workhorse, carrying well over 1 million vehicles a week.
And the unsung hero is this winding labyrinth of roads, the MacArthur Maze, connecting the Bay Bridge with 3 major freeways. Peter Hartlob is a local journalist.
It's the most essential stretch of highway in the Bay Area. You're going to use it to commute to work. You're going to use it to go to grandma's house. I mean, it's something that everybody knows and uses.
It's a rather complex and robust piece of engineering that takes 3 major arteries, Interstate 80, Interstate 580, and Interstate 880, through the East Bay and distributes them onto the Bay Bridge so you can head into San Francisco.
Originally completed in 1936 to coincide with the opening of the Bay Bridge, over the years the maze has evolved to truly earn its name.
We're approaching the maze. There's a flyover over me here. I think this goes to San Francisco. We've got one coming over here. I think it goes to Oakland. I'm not sure. I've lived here almost all my life. I still get lost on the MacArthur Maze. It is an absolute just bowl of spaghetti.
If you look at it from above, it's almost like looking at somebody's heart. There are so many arteries coming in and out of this distribution center.
While the maze might look like a gigantic mess, the engineering behind each intertwined section is very carefully designed for an area that's famous for earthquakes.
It was built extremely robustly and built to last. It was also built with the thought that this is earthquake country and there would need to be some flexibility in it. And that's why over the years, The MacArthur Maze has done well in earthquakes.
The maze stood firm against huge tremors that decimated the Bay Area. But in 2007, it was struck by something entirely unexpected. April 29th, a tanker truck loaded with gasoline was heading into the MacArthur Maze, en route to a fuel station in Oakland.
It was the early hours of Sunday morning. Very little traffic, very quiet on the roads.
Just before 4 a.m., the tanker hit a guardrail and overturned, spilling thousands of litres of gasoline. Thankfully, the driver escaped before the truck exploded. The unfolding disaster was caught on camera. Caltrans Communications Chief Bart Ney was at home when he heard the news.
I was in bed, I was asleep. It was 4 o'clock in the morning. And I was called by the Bay Bridge project manager. He said, turn on the news. He said, it doesn't matter what channel, just turn on the news.
Just 20 minutes later, as the fire and heat intensified, the top span of the maze suddenly gave way.
To witness, that much steel collapse in a fiery mess, it's scary.
Journalist Peter Hartlob knew a major catastrophe was unfolding.
We saw, just incredible flames, smoke throughout the Bay Area. You can see it everywhere, and we knew something huge had happened.
Fire crews fought for hours to control the blaze. By morning, the devastation was plain for everyone to see.
I didn't think it was possible to melt a steel freeway like that. And to watch watch a road that you've been over 1,000,000 times just fold like a taco, no words can describe it. It was really shocking. It looked like a war had happened.
Incredibly, despite the intensity of the inferno, no one was seriously injured in the disaster. But with the Bay Area's most important intersection decimated, drivers prepared for chaos.
When we saw what was going on in the East Bay, we knew this meant shutdowns for a long time. It was a huge, huge thing on people's minds from the beginning.
We're literally under the maze, the part that collapsed. A major truck thoroughfare. You'll see trucks moving across here as we're talking. There goes one. This is the heart of traffic in the Bay Area. If you lose the maze, then you're going to have gridlock throughout this entire part of the state.
The big question was, why had a structure that stood strong against some of California's most powerful earthquakes been destroyed by a truck fire?
Evidence in the wreckage showed that the structure had endured unexpectedly high temperatures.
There was so much volume of fuel here that it produced temperatures that the steel never should have seen.
Professor of Engineering Abul Hassan Astane Asal investigated the collapse.
When the temperature goes up, reduces the strength of steel. These are the bumps due to buckling of steel because it has lost strength. This was about half-inch thick plate.
As the heat intensified, the steel plate girders supporting the concrete roadway began to twist and bend, not only altering the shape, but crucially the strength of the steel.
Steel is an amazing material. We use it all over the place in bridges because it's so resilient. However, one of the things about steel is that you can mold it into different shapes, but it takes an immense amount of heat to do that, and you don't normally see that type of heat out on the freeway.
It's estimated that the blaze reached 1,000 degrees Celsius, around double the heat that the steel was designed to withstand.
1,000 degrees is around the same temperature as a volcano, burning within all this concrete and steel. But the intense heat wasn't the only problem.
Investigation revealed the exact location of the inferno made things far worse. Against the odds, it was directly below one of the main connections supporting the roadway above.
See that truck going across? The truck probably began its fall right about there on that curve, and it landed right there against that support. So it was literally the worst possible place for fuel to ignite because it was right underneath the steel.
Steel, it's good until about 500 degrees Celsius, like 1,000 degrees Fahrenheit. But at that point, it loses strength rapidly. So just one truck at one location, two of them collapsed.
We have an overturned truck that is spewing out something as hot as molten lava right under the freeway that everyone here uses to get to work, to get to grandma's, to get to soccer practice. Absolute disaster.
With traffic gridlocked and the economic impact estimated at around $6 million a day, officials knew they had to get this vital interchange back up and running fast.
This was quite easily the biggest traffic disruption we had ever seen in the Bay Area. Thousands of vehicles go through this area at any given hour. Time was absolutely critical because time means money, and delays in traffic affect everything.
Officials estimated the maze would take at least 50 days to repair. But what actually happened was nothing short of remarkable.
Less than 48 hours after the collapse, demolition crews removed the mangled section. And within days, construction was moving full speed ahead.
Girders are coming in, stuff's going up incredibly quickly.
Some steel came from Pennsylvania and it was fabricated in Arizona.
Just to get the girders up here, they've got two guys in a truck so that one guy could sleep and one guy could drive, and all they're doing is stopping to go to the bathroom.
Those people worked around the clock. And there was a giant welcome message on the steel when it arrived here from Arizona to the people of Oakland.
Just 26 days after the collapse, and crucially with increased levels of fire protection, the repaired MacArthur Maze reopened to traffic.
While modern fireproofing and thermal protection might help reduce the risk of collapse, if you're facing a freak accident and the flames as hot as a volcano, there's not much more you can do.
For me, it's not about the accident. For me, it's about how quickly this got done. Everybody coming together from places outside the Bay Area, and just an absolute miraculous amount of time.
The maze is still doing its job. It's still doing the thing it was designed for in the 1930s. It's getting people to their destinations, it's getting trucks where they need to go in the East Bay, and it's keeping America strong.
In engineering, safety and planning must always go hand in hand. Get the design wrong and safety goes out the window. Like this catastrophe in Australia, where a routine detonation turned to tragedy.
Everybody was looking forward to it. It was going to be something that we should tell our children about.
Thousands watching as a hospital demolition ends in devastation.
It wasn't what we were supposed to be seeing at all. Big chunks of metal flying into the lake.
And a blast that sent shockwaves across the nation's capital.
When you're using explosives in front of a huge crowd, you have to get things right.
Canberra, Australia, sits on the banks of the Molonglo River, surrounded by the Australian bush. This inland city was founded in 1913 to serve as the newly independent nation's capital. Journalist Emma MacDonald is a Canberra native.
Canberra is a very unique city because the government decided to launch an international competition to have Canberra designed. The plan at the time was a sort of futuristic city, really geometric. There's no very, very tall buildings. It's been kept at a low level. Some people love it, some people loathe it. I love it.
Canberra is one of the great planned cities of the 20th century. Every detail was meticulously sketched out, from its state buildings to its boulevards. And like every major city, Canberra needed a major hospital to support it.
Built in the 1940s, for 5 decades the Royal Canberra Hospital served the city from the shores of Lake Burley Griffin. But in the 1990s, the ageing hospital was closed, and its lakefront buildings scheduled for demolition. As journalist Verona Burgess explains, the decision wasn't without controversy.
Practically every family in Canberra had a connection with it. Somebody had been born there, somebody had died there, somebody had had their lives saved there. So it was a very big emotional and political topic when the government wanted to knock it down.
In an effort to get the public on board, the government invited spectators to attend the event.
It was the hospital that I was born in, and when it was demolished, the government touted it as a family day out. It was meant to be, you know, seeing a little bit of history come down. It was meant to be a safe and wonderful adventure for the family.
The plan was for the steel-framed buildings to be brought down with explosives.
In a controlled implosion, the structure should collapse within its own footprint. At least that's the theory.
Explosives engineer Dr. Graham Mackenzie explains.
The key to do it is take the columns out at the bottom of the building to start it moving down. Then each of the floors in turn, the columns supporting the top will be blown, then the next floor columns will be blown. So what's happening is the building's moving down. If it's off-centre, the building will go sideways. You want it to go straight down.
In a controlled implosion, the placement of the charges and the timing is key.
The concept is you use the minimum amount of explosive to facilitate the best progressive collapse. If you use the minimum amount, there's less likelihood of fragmentation, there's less likelihood of people being hurt.
Sunday, July the 13th, 1997, Demolition Day. Boats and huge crowds descended upon Lake Burley Griffin.
One of the largest crowds in Canberra's history, more than 100,000 people, gathered to witness the final stages of the demolition.
A 200-metre exclusion zone was enforced. Journalists Verona Burgess and Andrew Campbell were among the crowd.
I was at the Canberra Yacht Club, which directly looks across the lake, and it was quite a festive occasion because the government had wanted to make it a community event.
I was based here just on the bridge. There was a level of excitement and there was an air of anticipation in the crowd. Everybody was looking forward to it. We'd been told it was going to be something that we should remember and tell our children about. There were people literally only a few hundred metres away from the actual explosion site.
Shortly before 1:30 p.m.
It was two sets of explosions, basically. First one was a very small one, and then the second one much larger.
It was not anything like what we'd expected. You expect to see the building kind of collapsing in on itself and just a big cloud. But what happened instead was we started seeing bits spurting out the side of it.
For Verona, it was clear something had gone very wrong.
These bits of concrete and metal are flying into the lake. This isn't right. This can't be right. This isn't what it was supposed to be.
Instead of imploding, the blast shot shrapnel over the lake as far as 800 metres, 4 times the distance of the exclusion zone, directly at the crowds.
And then this big piece came sort of hurtling towards the yacht club, and I think that was when I realised this is actually a disaster.
While 9 people were injured, tragically 1 girl, standing about 400 metres away, or twice as far as the exclusion zone, was struck by debris and died instantly.
It was terrible. It was awful to think that this little girl had just lost her life for no reason.
We were there for the implosion, and we didn't anticipate that it would turn into a tragic event.
I still can't talk about it without just feeling so sad. It was just a hideous, terrible, terrible thing to happen. Everyone was in shock and it was just awful.
Canberra's citizens were demanding answers.
We all wanted to know who was at fault, and I think the most obvious was the local government, who'd literally told us all to come down and see it, and had hyped the event as being such a public spectacle.
There's little doubt that without a crowd there would have been no tragedy. But for the official inquest, one big question was why this routine demolition had turned to disaster.
The inquest found a number of failings, from too much explosive to incorrect cuts in steel columns. The list goes on. When all these things combined, it explained why this demolition went disastrously wrong.
The key problem was uncontrolled debris.
I don't believe that the right explosives were used. I don't think they were protected from producing fragmentation. The safety distances for the public were totally inadequate. There's a lot of hope and prayer. There was nothing else.
The coroner's inquest discovered that the original plan had been to use around 130 kilograms of explosives. In reality, almost 500 kilograms were used, a seemingly huge miscalculation.
That's around 3.5 times the amount of explosives required. That's massive.
Inspectors also discovered that there had been a last-minute change to the blasting configuration on the day of the demolition.
There was still a working hospice not too far away with patients who were unable to leave. So the explosives were placed so that the blast was in the other direction, which was towards the crowd.
This change meant the exclusion zone was now inadequate.
The possibility of fragmentation for steel flying large distances is high. The safety distance that applied to steel structures or anything to do with steel is much, much farther away.
An Army major giving evidence to the inquiries said that for a blast like this, the standard exclusion zone is around 1,000 metres, which is almost twice as far away as the main crowd was standing.
We were technically in the blast range, as it turned out. Parts of the hospital ended up at the National Library on the other side of the bridge.
Following the disaster, the inquest made a number of recommendations that it strongly suggested should be followed in the future.
One of the key proposals was that for all future demolitions, fully independent explosive experts and structural engineers should be consulted at every stage of the process.
A memorial acts as a permanent reminder of the tragic event that took place that day in the nation's capital.
An implosive demolition as a public spectacle is fraught with danger. Safety has to be paramount. That way, tragedies like this can hopefully be avoided in the future.
In engineering, every step from design through construction has to be rock solid. One mistake can bring everything crashing down to earth. Like this disaster in Illinois, a pioneering stadium brought to its knees.
I noticed right away that the roof had pancaked down.
Engineering errors that shook a community.
You knew you had serious injuries, and some of these people were our neighbors and friends.
The burning question, what had gone so catastrophically wrong? Chicago, Illinois lies at the heart of the third largest metropolitan area in America, with around 10 million residents. It's also home to one of the world's busiest airports, Chicago O'Hare.
Since the mid-70s, O'Hare has handled more than 500,000 flights a year, with tens of millions of passengers heading into Chicago. All of those people coming and going created an economic boom along I-90, which is now known as the Golden Corridor.
For O'Hare's neighboring community, Rosemont, the golden opportunity transformed the town. Todd Wessel is a local journalist.
You can't be any closer to O'Hare Airport than Rosemont. There are several cities that actually abut or touch Rosemont property, but the uniqueness of Rosemont is that it has an expressway-like road that goes in and out. It is really the only entrance in and out of O'Hare Airport, and thus the development of Rosemont.
Rosemont might be small, but thanks to the Golden Corridor, it punches well above its weight.
Rosemont is probably one of the most unique towns in the entire country. It's a town of 4,200 people, but it is home to a 20,000 seat stadium, convention center, luxury theater, and it's an entertainment destination for a lot of people in the Midwest and the Chicago area.
In 1980, this small town gained a major new landmark, this vast multi-purpose arena, originally known as the Rosemont Horizon.
The stadium has hosted everything from ice hockey to monster trucks, as well as live music from major artists like the Rolling Stones, U2, even Madonna.
Inside, the 20,000-strong crowd had an uninterrupted view of the action, thanks to the giant self-supporting roof.
Constructing an arena this size is always a massive engineering challenge, but building one directly under the flight path of Chicago O'Hare gave engineers a real headache: noise.
As you can see, many, many thousands of planes travel very, very close to the arena, and they fly down the Kennedy Expressway and land right at the airport.
But jet engines and live music don't mix. So engineers came up with a clever solution. Instead of steel or concrete, they would use wood. Professor of Engineering, Dr. Solomon Kadira explains.
The reason why the Rosemont Horizon roof was to be wood versus steel, which is common to use for roof, wood is much better noise insulator compared to steel.
Wood is full of tiny gaps or pores, which help to trap air molecules, dampening sound from the outside world.
The fact that this arena is close to O'Hare, many planes going on top of it, and you definitely want to deaden the noise inside the arena.
Construction on the $19 million stadium began in September 1978.
The main structure of the arena was relatively simple, essentially 4 stories of concrete, but the epic wooden roof was unique.
16 wooden arches resting on 32 concrete buttresses would span almost 90 meters across the stadium, with hundreds of girders bolted between them, creating a solid frame, topped off with wooden planks and a 2.5 centimeter thick weatherproof canvas sheeting.
At the time, this was the largest commercial roof of its kind east of the Mississippi. It was an engineering masterpiece.
During the summer of 1979, the gigantic wooden roof was taking shape.
When they were building the Horizon, it was special to have it here. It was something we were all very excited about having.
On August the 13th, 18 workers were on the roof installing the final 2 arches. Just after 8 a.m., without warning, the innovative wooden frame collapsed. Journalist Todd Wessel heard the news.
I've heard something bad had happened at the site of the Rosemont Horizon. I immediately got in my car, drove out here, and I noticed right away that there was a disaster and the roof had pancaked down.
A firefighter at the time, Roy McCampbell, raced to the scene.
It basically looked like a lumber yard because it was just a pile of lumber at that point. The wood didn't look damaged. It looked like it had just all fallen over. You knew you had serious injuries, and some of these people were our neighbors and friends.
Rescue crews from surrounding communities helped scour the wreckage.
It was obvious that the devastation was total. The scene was chaotic. I remember seeing A fireman I've known for 40 years, he was crawling on top of the roof looking for survivors.
Our goal was to ascertain who needed care and if we could find people that were injured at that time. There were other members of the teams working to find people that were buried.
Rescuers freed many of the trapped workers. While 16 were injured in the collapse, tragically 5 lost their lives.
The deaths of many people due to the collapse, that was just awful. You could always build a new stadium, but you can't replace the people who passed away.
The authorities immediately launched an investigation. The concrete structure was unscathed, so something must have gone wrong with the wooden frame.
One of the reasons that was speculated on are the planes in and out of O'Hare International Airport. Planes, when they come over buildings, of course, they produce large amount of noise, decibels very high. If they are very low, they also will affect the wind flow, wind pattern.
Jet wash can create waves of air pressure, but engineers didn't think that that alone could explain the collapse, and dug deeper for problems within the structure itself.
Closer inspection revealed the real issue lay in the method of construction, which had left the roof unsteady.
The reason why the Roseman Horizon roof failure occurred is because of global instability. The entire structure globally was not connected.
In the design, hundreds of smaller girders were supposed to be connected to the giant arches using angle irons, each secured with 3 bolts. But the investigation revealed that less than half the bolts were in place, and hundreds of those had no nuts fitted.
The members were not connected rigidly to each other during construction. They were apparently in the process of connecting them, but also there were some bolts that's missing. More than 53% of the bolts were not installed.
Yet, it turns out that was part of the plan.
They wanted to keep the roof as a flexible roof. If you install all 3 bolts and make it stiff, make it tight, rigid from the beginning, then what happens when the entire roof wants to settle down? Then there is some resistance to that settling, which creates some strange force distribution. So what they decided is, let's just install 1 bolt connecting the arch to the girder, let the structure be flexible.
Engineers knew the roof would be unstable until fully secured. So steel plates, known as compensating plates, were bolted where the girders met the arches to keep things steady during the construction phase.
The compensating plate that was supposed to be installed on the top of the arch, connecting all those members together, it was either not properly installed or it was not installed at all.
Although they were essential to stability, barely 1/4 of the plates were properly installed. The entire roof structure was a house of cards, just waiting to fall.
There was yet another problem.
One reason that contributed to the lateral instability is when they were building the roof, they were stockpiling materials on the side of the structure. So at certain locations, they were what we call concentrated load. It is not a uniform load. That load was they're just stockpiling, and from the calculation that done later, that stockpile of materials and light equipment and the weight of the workers exceeded the maximum that's allowed by more than 50%.
Now all it needed was a nudge.
The wind was blowing on the side of the arches. That also contributed to the lateral instability of the arches. So all of those reasons combined contributed to the global instability of the roof that caused the collapse.
The National Weather Service at O'Hare reported winds of less than 23 kilometers an hour at the time. It really didn't take much to bring the roof crashing down.
The collapse devastated the community. However, the city of Rosemont was determined to rebuild. This time, every single critical piece was fully in place.
Anytime there is a collapse, the construction industry, the engineering industry learn from any collapse. There's nothing better than learning from failures to avoid the failure in the future.
The Rosemont Horizon finally opened to the public in May 1980.
Once the stadium was built and ready to go, we attended the very first show here, George Burns and Kenny Rogers, and we knew from the get-go that this was going to be a real winner for our community.
More than 4 decades later, the stadium still stands in honor of the workers who died on that tragic day in 1979.
I never forget the sacrifice that was made. I never forget the day, because I think the people that sacrificed needed to be remembered, the events needed to be remembered, and there's part of history here.
When building big, every component, no matter how small, is crucial. Get it wrong and catastrophe can be just around the corner. Like this failure in Michigan, a nightmare on a major highway.
It was one of the worst segments of road that I've ever driven on in the United States.
A shortcut that drivers would rather avoid.
People were choosing to drive for an extra hour just to stay off this road.
A freeway that failed to stand the test of time.
Just deteriorated very quickly, and obviously much too quickly.
Grand Rapids, Michigan was founded in 1826 and thrived thanks to the powerful Grand River that flows through it. Jim Hager is a local journalist.
We are right in the heart of downtown, and the Grand River is behind me. The Grand River is the largest and longest river in Michigan, and it runs through Grand Rapids.
The river behind the rapids drove this city's success.
150 years ago, this river served as a primary transit arm for the logging industry. You didn't have trucks, you didn't have trains, you had the river and the logs would float down the river until they got here.
As the city grew, the Grand was dammed to provide power for industry, while the existing river traffic moved over to rail and road.
We've created these rivers of concrete, and they become vital to our economy. You need good roads.
Back in the 70s, the state identified one route south of the city that would be essential for future growth, the Paul B. Henry Freeway, known as the M6.
The M6 is a 20-mile freeway that was built in the early 2000s. This expressway is considered a significant shortcut for the people traveling from Chicago to Lansing and anywhere in outstate Michigan.
The M6 was designed to deliver a smooth ride for decades to come, thanks to an age-old material, concrete. Dr. Angie Okono is a civil engineer.
Concrete sounds very simple, and yet it is very complicated. You have to be very careful about the exact ingredients. So this is the stone. As you can see, it's very coarse. And then this is the sand. It's really fine with a size less than 5 millimeters.
Once those materials are mixed with cement and water, there's only one ingredient left to add.
We think of concrete as a hard, densely packed material, and it kind of is. But for road building, especially where winters are harsh, there's an unexpected ingredient: air.
A special resin is added last to create these all-important air bubbles.
As temperatures change with the seasons, these tiny pockets of air allow the concrete to expand and contract without cracking. Getting the bubbles right is vital.
The $700 million M6 took 3 decades from planning to construction. Finally, in 2004, to the relief of road users, this shortcut opened to traffic.
Usually when you lay concrete on a road as a pavement, you expect it to last 50 years before having to carry major maintenance work.
As local engineer Jade van der Kamp knows, getting roads like this right is vital for a nation reliant on its automobiles.
In the United States, we drive everywhere. This is how we get from point A to point B. And having the infrastructure to do that is incredibly important.
But after only 7 years, it became clear that the M6 had a serious problem.
It just deteriorated very quickly, and obviously much too quickly. It just began developing these giant potholes, and not just the size, but the number of them. It was just a pothole-filled road.
By 2017, a 6.5-kilometre stretch had become a daily nightmare for 50,000 commuters. Jade was part of the team tasked with assessing the problem.
The worst part of that road was like driving over inverted speed bumps, essentially. So if you think of when you drive over a speed bump going down the road, you typically slow down a lot, except now you're doing them at 50 miles an hour or 70 miles an hour. And it really was quite violent. The whole vehicle would shake. It was one of the worst segments of road that I've ever driven on in the United States.
Analysis of vibration levels revealed the road wasn't just bumpy, but a risk to vehicles.
It was surprising, but we found that in the 4-mile segment, which we're on right now, that segment especially would do 10 times the normal amount of damage for what you would expect in a highway setting. A road where people are, that's their daily commute, that is that violent, is going to do significant amounts of damage to your vehicle.
The road was clearly falling to pieces. The question was why. The region's weather immediately came under the spotlight.
In West Michigan here, it's lovely in the spring right now. It's beautiful in the fall. It's gorgeous in the summer. However, our winters are brutal.
Those harsh winters take a heavy toll on the roads.
The temperatures will rise above freezing during the day. The sun will melt the snow, and we'll have wet roads, and they'll be moist. And in the evening, when it gets colder and below freezing, it turns to ice.
With time, most roads develop cracks, and when it rains or snows, water gets in. Now, that's no problem in the warmer months. But in the winter, when the water freezes, it causes the cracks to grow.
And then this cycle is going to repeat again, because then the next time that you have a freeze, because you have the micro cracks, you have more water seeping in. Again, it's going to freeze, expand, and then you're going to keep propagating the micro cracks.
But the cold weather alone didn't explain the speed of the failure. A closer inspection revealed a hidden flaw. The very thing that should have ensured the integrity of the concrete, the air bubbles.
Analysing the concrete, experts believe the bubbles, although already tiny, might have been too small, the result of using new, untested resin to create them.
The state's Department of Transportation also suggested that the journey from the concrete mixing location to the construction site could have played a part.
Ironically, transporting the concrete on rough roads before it was poured might have shaken some of the air out of the bubbles.
With the bubbles too small to do their job properly, harsh salts and the freeze-thaw cycle rapidly accelerated the damage, causing the M6 to crumble. In 2017, a $9.5 million project was announced to replace the failing concrete on the worst affected parts with new asphalt.
When we found out it was going to be replaced, I think the initial reaction was finally.
After a 6-month closure, the M6 reopened to the relief of local drivers.
My personal experience was it was great to be able to use all the lanes again. It was so much smoother than it had been, and I didn't avoid it anymore.
It was nice. I mean, it's went from probably the worst road that I've ever driven on to one of the nicest roads that you've driven on.